This is section 9.6, solving a system of equations by graphing. So a systems of equations just means you have two equations to graph on the same coordinate grid, and then we'll talk about the solutions they have. So 9.5, we graphed an equation in slope-intercept form. So we're going to do the same thing here. Our first point comes from this -2, and that is your y-intercept. So on the y-axis, we're going to go down to -2, and that is our first point. Then the slope here is the number in front of x, which there's a 1. So that means the slope is +1. And normally it's rise over run, so I put 1 over +1, which means from this -2 point, you rise up 1 and run to the right 1. So I'm going to continue that pattern until my points are off my graph. And instead of going up and to the right, I can reverse it and go down to the left for some other points. And it's important to use a straight edge or a ruler to connect these points to make a line. And make sure you have arrows on both ends of your line. The second line, I'm going to use red so you can see the difference. We're going to start here on the y-intercept of +2. So this is up 2 from the origin. And this slope is -1/3. So I'm going to make the negative up with the numerator. So -1 means I drop down 1, but go to the right 3. So this point, or I can go up 1 and to the left 3. And again, take a straight edge or a ruler and connect these dots to form a line. Again, the line must have arrows. So, determine the solution. My solution is written as an ordered pair, and that is located right at this intersection point. So when I solve a system, I'm looking for the point that they have in common where they're going to be equal. So if I write it as an XY ordered pair, this location is 3, 1. So 3, 1 is my solution. Part 3, we need to check our solution. So we're going to do our checks down here. So if I look at the first equation, it's y = x - 2. If I think my x value was 3 and my y value was 1 in my ordered pair, you replace those variables. 3 - 2 is 1, and that equals 1. So this checks out in equation number 1. If I look at equation 2, we started with y = -1/3 x plus 2. Again, if I think y in the ordered pair is 1, but x in the ordered pair was 3, I'm going to solve the right side. So y1 equals -1/3 of 3. These 3's cancel out. You're left with -1 plus 2, and that's +1, which equals +1. So it checks in both equations. So one type of system is 2 intersecting lines that share 1 point in common, and that's your solution. The second type we'll talk about is a different type of solution. So we're going to graph them in the same way. Start with your y-intercept. So this is on the y-axis at +1. Then my slope here, there's an invisible -1. So again, I'm going to write that as a fraction, -1 over +1 for the run, which means I go down and to the right. Or I can reverse it and go up and to the left. Connect those dots with a straight line. That one's bad. Let's try again. Here we go. Let's try it one more time. Sometimes this technology isn't the best. Here we go. There we go. All right. The next line I'm going to graph in blue. Start at -3 on the y-axis. So you're going down to -3. My slope here is -1. So -1 over +1. Again, I'm going down and to the right or up and to the left. Now you should see that this graph looks different from the first one. Okay, the first one intersected at a point. These do not. These are what's called parallel lines. So since they never intersect, we need to think about what that means in terms of the solution. And since these never crossed, your solution is there is none. There will never be a point where these two have in common. So on homework, if you get parallel lines, your solution is no solution. So make sure you write that out in words. And you can tell from the equations that the slope was the same in both equations. You both had a -1, so that makes them tilt the same way, but different y-intercepts. So if you look at the equation right away, you notice the same slope, you can predict it's parallel lines, which means no solution. So basically you need one positive slope, one negative slope for them to intersect and cross. There is one more type of solutions. So let's graph this last example. We're going to start with +4 on the y-axis. My slope is -2 or +2. Again, if it's just a whole number, put a 1 underneath. This is both positive, so I'm going to rise 2 and go to the right 1. Or if you reverse it, go down and to the left. Again, graph it with a straight edge, arrows at the ends. All right, if you notice, equation 2 is not solved for y, so I need to get the y alone first. So I need to rewrite this equation so that y is on the left side by itself. So we're going to add x to both sides. You get 1/2 y equals x plus 2. To undo the 1/2, you're going to multiply by 2. I need to group this other side and multiply each piece by 2. So if you distribute, that's 2x plus 4. So this is the line that you're graphing now. And if you notice, from the beginning, we have y equals 2x plus 4 for my second line, and the first one was y equals 2x plus 4. So these are the exact same line. It's going to be one on top of the other. So when you have the same exact line, same slope, same y-intercept, that means every point they're going to have in common, so your solutions are infinitely many. So here's just a quick chart, and this is in your notes. So there's 3 types of systems of equations. I can have 2 intersecting lines, so there's one solution, which is the intersection point, because you have one positive slope and one negative slope, so different slopes and different y-intercepts. Then you have parallel lines, which will never intersect, so their solutions is none, and they have the same slope but a different y-intercept. Then finally, the last one we did was the same exact line. There's infinitely many solutions because the slope and the y-intercept are the exact same, so they share every point in common.